All right, reasoning in geometry. This front page, 2/3 of it, you should already know. You may not know you know it, but you do. So the addition property of equality, we'll start with that one, says if A equals B, then A plus C equals B plus C. You do that all the time. You know if you do something to the left-hand side of an equation, you must also do it to the right-hand side of the equation to keep the equations balanced. If I'm adding to both sides, then that's going to be using the addition property of equality. So in the same way, the subtraction property is going to say if A equals B, then A minus C equals B minus C. I suspect you can do the multiplication property as well without me even telling you what you need to write. If A equals B, then A times C equals B times C. Same thing for division. If A equals B, then A over C equals B over C. Now this one has a caveat to it because I cannot allow C to equal 0. Why is that? Why can C not equal 0? Because I'm dividing by it, and at this point in your mathematical career, you do not know how to divide by 0. Division by 0 is undefined. So you have to add on that C is not 0 for this property. The distributive property is the one that we all know and love. No one ever forgets this property. A times B minus C equals AB minus AC. And the substitution property, which you use all of the time as well without probably realizing you do it, says if A equals B, then B can be substituted into any expression in place of A. Now these last three are in a box. They're new. They're the ones that you're going to use in geometry more specifically than the ones up above. The first one is the reflexive property of equality. Now if you'll remember when we were looking at vertical angles and I told you that vertical angles were going to be your very best friend and you were going to love them because every time you saw vertical angles you would know they were congruent. Well, the reflexive property is your second very best friend and you're going to use it a lot. And you're going to think, well, this is the dumbest property I've ever seen because this property just says A equals A. How do you remember all these properties? Well, the word here is reflexive. What is the root word of reflexive? The root word is reflect. Now, some of you are going to write this the reflective property. Please don't do that. It has an X in it. The word is reflexive. But when you hear the word reflect, which is the root word here, reflect makes you think of a what? It makes you think of a mirror, and that's what this is. It's basically just a mirror property. It says A equals A. The symmetric property is a property of equality. It can also be a property of congruence. But the important thing to realize when you are using the symmetric property is there must be equal signs in what you are looking at. This property says if B equals A, then A equals B. Equal sign. Equal sign. There is another property that you are supposed to already know that looks a lot like the symmetric property, but it isn't the symmetric property. That property, we'll put it down here, that property is the commutative property. And the commutative property is either the commutative property of addition or it is the commutative property of multiplication. It is not a property of equality. The commutative property says that I can have, for example, 3 times 4, and that will be exactly the same as 4 times 3. That would be the commutative property of multiplication. There's only one equal sign in there. I am turning the numbers, their order is changing around an operation symbol. It's changing around the multiplication sign. When I'm using the symmetric property, the order is changing around an equals sign. This is a property of equality. This is a property of multiplication. Again, I could say 4 plus 3 equals 3 plus 4 and call it a property of addition. These are going to, the commutative property is a property of operation. The symmetric property is a property of equality. The change is occurring around an equal sign. The transitive property, the clue for remembering the transitive property is that it has 3 parts to it. The transitive property says if A equals B and B equals C, then, take a guess. What do you think? Exactly. Then A equals C. You go, that looks an awful lot like syllogism, and it does. But again, this is a property of what? It is a property of equality. Syllogism is a method of reasoning. We use a lot of words when we're using syllogism. We are looking at statements when we're talking about syllogism. When we are using the transitive property, we are using equal signs, or again, it could also be a congruent sign. All right, flip that open. Mine doesn't have an inside. I messed up my first one. All right, so here is an example of how we will use these properties. Some of you had to do this in Algebra 1 and you didn't like the teacher for making you do it very much, but there was a reason that you had to do that, and this is part of it. So I am given 5x minus 12 equals 32 plus x. What am I going to do to get from 5x minus 12 to 5x that I do exactly the same thing to get from 32 plus x to 44 plus x? What has changed? What has changed is the 12 is gone and the 32 has become a 44. How do you do that? How do you get from negative 12 to 0 in the same way you get from 32 to 44? Well, you add 12 on both sides, which means you have used the addition property. And that is the addition property, again, of equality, because the thing that is changing around an equal sign. How do I get from 5x equals 44 plus x to 4x equals 44? What is different? How did I get from 5x to 4x? How did I get from 44 plus x to 44? Well, I subtracted x on both sides. So that is subtraction, the subtraction property. And I'm pretty sure everybody knows that this last one is division. Okay, give the property which justifies each statement. If x equals y and y plus 4 equals 3x, then x plus 4 equals 3x. What has changed? That's the question that you ask yourself every single time you do one of these problems. What is different? What changed? How did I get from x equals y and y plus 4 equals 3x to x plus 4 equals 3x? If all of this, then this. How did I get this knowing this? What's different? Well, y plus 4 is now x plus 4. 3x didn't change. So what's the only thing that changed? Well, this has an x in it, that had a y in it. Why is that okay? Well, that's okay because x and y are equal. So what did I do? Well, I replaced the y with the x, which means I used substitution, right? I used substitution. I replaced y with x. Second statement. If x plus 4 equals 3x, and that's supposed to be then 4 equals 2x. What did I do? How did I get from x plus 4 to 4? How did I get from 3x to 2x? Well, this is missing the x, and that one's one less. So what did I do? I used subtraction. And what did I subtract? I subtracted x on both sides, right? If P is congruent to Q, Q is congruent to R, then P is congruent to R. How many parts are there? 1, 2, 3 parts, and these are the same. They overlap, which means they kind of just go away. So if P is congruent to R and Q is, if P is congruent to Q and Q is congruent to R, then P is congruent to R. This is absolutely a classic example of the use of the transitive property. So now let's use this for an actual problem. I started out looking at this picture and it's like, well, this is something we've done before. We should all at this point know that AB plus BC equals AC. And if you look at your notes from that, there's a reason that I can say AB plus BC is equal to AC. We didn't talk about it too much at that point, but that is using what is called the segment addition postulate. It's okay to put the two little pieces that sit right next to each other together and get the long piece, the segment addition postulate. Now, if I know AB plus BC equals AC, why can't I say 4 plus 2x plus 15 minus x equals 21? Why is it okay to do that? How did I get from this statement to this statement? Well, I replaced AB with 4 plus 2x, I replaced BC with 15 minus x, and I replaced AC with 21, so that was using substitution. Now the next statement that I make is a little harder sometimes to understand what happened. How did I get from 4 plus 2x plus 15 minus x equals 21 to 19 plus x equals 21? Mathematically, I did the thing that is the most logical to do as a next step. But what did I really do? Well, I put the 2x together with the minus 1x, and I put the 4 together with the 15. What do we call that when we do that? Don't overthink this. The reason here is just simply combine like terms. Then how do I get from 19 plus x equals 21 to x equals 2? I'm going to subtract 19 on both sides, so that's using subtraction. All right, going to take another little break, and I'll finish up in a minute.